everyone, this is a video that illustrates why you do not need to graph your functions to evaluate limits when there's polynomials. This video we're not doing the laws, so I'm doing the laws on the next video. So basically I made these three. So I have the left-handed, the left-sided limit, the right-sided limit, and the limit you're usually given like this. So I'm going to illustrate why you don't need to do these two. So what I'm going to do is graph it. So basically this one, if you set this to f of x equals x squared minus 8x plus 12, and then set this to 0 and factor, you get your solutions, or your x-intercepts, as x is 2 and x is 6. So I already did that. So this is your 2 and 6. So when y is 0, we have these two intercepts. I also went ahead and plugged in the 4 so I can get my minimum here on the graph. And when I plugged in 4, I got -4. Okay, so for the limits, also my y-intercept is 12. It doesn't go, so it's going to go up in here. We're trying to find the limit as x approaches 1 of this graph here. Now, if you take the left side, here's your 1. You're coming down around here to 1. Right side limit, you go this way. And the way you're going to find the limit, if you notice, this is smooth and continuous. It doesn't have any holes, or it doesn't have any big jumps like we did last class. So when you have a polynomial that looks like that, you don't have to graph. All you're going to do is plug in the 1. So the limit as x approaches 1 of x squared minus 8x plus 12, and you just plug in the 1 into the x's. You get 1 minus 8 plus 12. So that's 13 minus 8, and that gives you 5. So at 1, let's go up to this. 1, 2, 3, 4, 5. You're right here. That's the limit. So it's just your y value. It's just if you put in f of 1. So if I change this to 1 and plugged in 1. And you can do that for all polynomials. So from now on, you don't have to graph. You're going to have to, sometimes we'll have to look at graphs, but polynomials you don't. Here's another one I did. Here's this one. I went ahead and made this. This is really like x minus 1 squared times x plus 3. And I set this to 0. So my solutions are x equals 1 and x equals -3. So there's your 1. There's your -3. My y-intercept is right there, 3. And then since the degree is 3, I started here in quadrant 3. Multiplicity is 2 here. So I just touch this 0 and then swing back up and end in quadrant 1. So that's the graph. But if you notice the graph, it's smooth and continuous. All polynomials are smooth and continuous. So we don't have to take right-sided and left-sided limits. All we have to do is plug in 1 into our equation. So all we have to do is say the limit as x approaches 1 of x cubed plus x squared minus 5x plus 3 is, and you just plug in 1. 1 plus 1 minus 5 plus 3. And that's going to equal 0. These two are 5. So that's 0. And there it is, your limit right there. Okay? And just for a reminder from probably Algebra 2, some of your types of polynomials. I put this here so you can see it. These are all polynomials. So anytime you have a polynomial that looks something like some of these, you can just plug in the value. The next video, we're going to be going over laws, limit laws, that will also help us as well. And that's it. Thank you. Have a nice day. Bye-bye.